Astronomers thought they understood the universe until the James Webb Space Telescope saw this. Not galaxies, not stars, but something far bigger, an invisible structure stretching across space, quietly controlling everything. Scientists expected randomness. Instead, they found patterns, massive threads, enormous voids, almost like a hidden design. And here's the unsettling part: nothing we can see has enough gravity to create it. So what is actually holding the universe together? And why are we only seeing it now? Something strange was hiding in the data long before anyone fully understood it. When astronomers began analyzing this deep patch of sky using the James Webb Space Telescope, they weren't looking for anything unusual. They were simply trying to map distant galaxies. But the deeper they looked, the more the images started to behave differently. The light coming from these galaxies wasn't arriving in a straight line. It was slightly stretched, bent, and subtly distorted, as if something massive was sitting between us and them, warping space itself. At first glance, these distortions seem insignificant, but when scientists examined hundreds of thousands of galaxies together, a pattern began to emerge, one that couldn't be explained by anything we can actually see. To capture this effect, JWST focused on a tiny region of the sky, just over half a square degree, and observed it continuously for about 255 hours. Within that narrow window, nearly 800,000 galaxies were analyzed. Each one acted like a probe, carrying information about whatever invisible structures its light had passed through on its journey to us. When all those signals were combined, something remarkable appeared. Not a random distribution, not noise, but a coherent structure, subtle at first, then increasingly clear. A pattern of mass that wasn't emitting light, wasn't visible, and yet was clearly shaping everything around it. This technique is known as gravitational lensing, and it works because gravity bends light. But here's the key detail: what's bending that light isn't something we can directly detect. It doesn't glow, reflect, or absorb anything. It simply exists, revealing itself only through its influence. And this is where the discovery takes a turn. Because once scientists confirmed that these distortions weren't errors or artifacts, they realized they weren't just observing galaxies anymore. They were mapping something far bigger, something invisible. And as that map came into focus, it revealed a structure that completely changed how we understand the universe. Which brings us to what that structure actually looks like. What emerged from the data wasn't chaos, it was structure. A vast, interconnected network stretching across the universe, forming what scientists describe as a cosmic web. This wasn't a loose or random pattern. It was organized, consistent, and surprisingly intricate. Instead of galaxies being scattered across space, they were arranged along long, thread-like filaments, connecting massive clusters across enormous distances. Between these filaments were vast, empty regions, cosmic voids where almost nothing exists. The entire universe, at its largest scale, suddenly looked less like a random explosion and more like a carefully woven system. What makes this even more fascinating is that this structure had been predicted decades ago. Theoretical models suggested that shortly after the Big Bang, an unseen form of matter began to clump together under gravity. These clumps formed the first framework of the universe. Over time, ordinary matter, gas, stars, galaxies, fell into these regions, building everything we can observe today. And now, for the first time, that invisible framework isn't just theoretical, it's mapped. The data reaches back billions of years, allowing scientists to see how this structure evolved over time. It shows that galaxies didn't form randomly. They followed paths already defined by something deeper, something hidden beneath everything we see. This changes the way we think about the universe. Galaxies are not independent objects floating freely through space. They are part of a much larger system, guided by an unseen structure that dictates where matter gathers and where it doesn't. But here's where things get even more interesting. When scientists look closely at the details, they notice that the structure isn't perfectly smooth. Some regions are more clumped, more irregular than expected. These subtle variations might seem small, but they could hold the key to understanding how this invisible component actually behaves. And that realization leads to an even bigger question. If we can now see the structure shaping the universe, what does that mean for everything we thought we understood? This discovery marks a shift from guessing to measuring. For years, scientists relied on simulations and indirect evidence to understand how the universe is structured. Now, with observations from the James Webb Space Telescope, those models can be tested with real data at an unprecedented level of detail. The large-scale structure revealed by this map strongly supports existing theories about how the universe evolved. It confirms that the unseen component we've been tracing is not just present, it plays a central role in shaping everything. It acts as the underlying framework, guiding how galaxies form, cluster, and evolve over billions of years. But this is not the end of the story, because with higher precision comes new challenges. Small differences between observations and predictions are now becoming visible. These differences could point to gaps in our understanding, subtle clues that the behavior of this invisible matter might be more complex than we assumed. Another important aspect is scale. The map created by JWST is incredibly detailed, but it covers a relatively small area of the sky. To fully understand the universe, scientists need to expand this method across much larger regions. That's where the next generation of missions comes in. The Nancy Grace Roman Space Telescope will scan vast areas of the sky, while Euclid is already working to map the large-scale structure of the universe across enormous distances. Together, these missions will combine depth and scale, creating a more complete picture than ever before. And this is the real transformation happening right now. We are no longer just observing the universe, we are decoding it. We are moving from broad ideas to precise measurements, from theory to evidence. Because once you can map the invisible, the next step is understanding what it actually is. What we've just explored is more than a discovery. It's a new way of seeing the universe. The James Webb Space Telescope didn't capture this invisible structure directly, but it revealed its presence with extraordinary precision. For the first time, the cosmic web is not just an idea, it's something we can map, study, and begin to understand. And yet, the biggest mystery remains. We can trace its influence, measure its effects, and map its structure, but we still don't know what it truly is. So here's the real question. What if the thing shaping the entire universe is something we've completely misunderstood? Drop your theory in the comments. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.